Okay, let's look at some squares, and now we're going to go on to square roots. So the following chart shows factors for whole numbers from 1 to 8. So all the factors of 1 are 1. Only 1 divides into 1 evenly. For 2, 1 and 2 both divide in evenly. 3, 1 and 3, 4. You can divide by 1, you can divide by 2, and you can also divide by 4, etc. I want you guys to fill in the rest of the chart. So what are all the numbers that would go into 9? Compare those with a friend, someone who's sitting beside you, whatever, and answer these questions as well. Which numbers have only 2 factors? Which numbers have an even number of factors but more than 2 factors? Which numbers have an odd number of factors, and what do you notice about these numbers? You answer those questions, working together with the partner to check answers. Pause the video right now to do that if you haven't done it yet. Now that you've finished that, we can go on to the other things here. So here are 2 ways we can tell if a number is a perfect square. So you can, number 1, if you can write a division sentence where the divisors, so that's the number you're dividing by, and the quotient, which is quote-unquote answer, are the same, then it is a perfect square. So for example, let's say we have 64. We can say 64 divided by 8 is equal to 8. So this is my divisor. This is my quotient. And just because I'm naming things, may as well name this one too. This is the dividend. Okay, so these are, if I can write 64 divided by 8, and it equals 8, so the divisor and the quotient are the same thing, 64 is a perfect square. Also, if the number has an odd number of factors, because, whoa, that should say one factor occurs twice, I'll have to make a change there, because one factor occurs twice. I don't want that. Go away. Goodbye. Thank you. One factor. There we go. Then it's a perfect square. So for example, if I want to write all the factors of 64, what numbers go into 64 evenly? Well, 1 does, obviously, because it goes into everything evenly. 2. 3 doesn't. 4 does. 5 doesn't. If 3 doesn't, then 6 can't, because 3 is a factor of 6. 7 doesn't. 8 does. And then really what you should be doing is, if you're doing factors, 1 goes with 64, 2 goes with 32, 4 goes with 16, and 8 goes with itself. So if we count the factors, 1, 2, 3, 4, 5, 6, 7, there are 7 factors, 7 is odd, therefore 64 is a perfect square. Okay, so multiplying a number by itself is called squaring that number. Just like if you have a square, to find the area, you multiply the number by itself. That's why it's called squaring. When we take the square root of a number, we're undoing that square. So to find the square root, it says, oh, I have a square. What is one side? So what is the root of that square? So we find the number that can be multiplied by itself to give us that number. Squaring and taking the square root are called inverse operations, so they're inverses. That means they undo each other. So 4 times 4 is 16. The square root of 16 is equal to the square root of 4 times 4, which is the square, which is just 4. Because, oh, I'm going to actually add one thing in here, sorry. That's the square root of 4 squared, and that's just 4. Because the 4, or the square and the square root undo each other, so I'm just left with 4. It's kind of like saying, what's 4 plus 8 minus 8? Well, you'd be back at 4. Or 4 times 2 divided by 2, you'd be back at 4. Because the multiplying and the dividing undo each other, here squaring and square rooting undo each other. So let's find the square of each number. So 5, what is the square? I'm going to look at 5 let's write it first as squared. 5 squared is equal to 5 times 5, which is 25. The square of 25, so I want 25 squared, that's 25 times 25, which, unless my memory does not serve me correctly, is 525. Okay, so that would be 25 squared. Now if we want to find the square root, so for example we're going to find the square root of 64, we're looking for the number that multiplies by itself to get 64. So we could make a square with 64 squares, and this would be, if we count across, we got 1, 2, 3, 4, 5, 6, 7. Oh, let's draw one. Okay, so we're going to make a square. Now if we wanted to count all of these, there would be 64 squares in there. And it's 1, 2, 3, 4, 5, 6, 7, 8 across. And 1, 2, 3, 4, 5, 6, 7, 8 down. Good. So the square root is right there. The square root of 64 is 8. We can also factor it. So we had factored 64 up there. So the factors are 1. I don't know why that keeps showing up. That's really annoying. 1 and 64, 2 and 32, 4 and 16, and then we have 8 and 8, and it's right there. So the square root of 64 is 8. Let's write the factors of 136 in ascending order. Ascending meaning going from smallest to largest. So the factors of 136 are 1 and 136. I don't know how many there are, but I'm going to split them up. It's even, so I know 2 will go into it, and that'll go in 68 times. 68 is still even, and there's another way we can tell for 4. Sorry, let's not jump to 4. Let's look at 3. If you're not sure whether 3 will go in evenly, we've talked about this before, add up all the numbers, so 1 plus 3 plus 6 gives you 10. 3 doesn't go into 10 evenly, so it won't go into 136 evenly. So we're going to skip 3. For 4, if I look at, I divided by 2, and I got an even number, so therefore I know 4 is going to go in. I could also look at my last two numbers. So 36, and 4 goes into 36 evenly, so it'll go into 136 evenly. Just a little division trick. So that'll go in 34 times. 5 won't, because to be divisible by 5 it needs to end in a 5 or a 0. 6 won't because 3 won't. So if a factor of a number won't go in, the multiple won't go in. So we're at 6, 7. Let's see, 7 won't go in. 8 I know will, because if I look at 4, it left me an even number. And 8 is 2 times 4, so 2 goes into 34. So it's going to be 8 times 17. 3 didn't go in, so 9 won't go in. 10 won't go in, because it doesn't end 0. 11 won't work. 12 won't, because 3 won't. 13 won't, because 13 divided by 13 would be, 13 would have to go into 6 evenly. It doesn't. 14 won't, because 7 won't. 15 won't, because 3 and 5 won't. And now we're at 16, and well, it would have to divide by something smaller. So 8 and 17 are the last partners. Once I get to 17, I don't have to check anymore because I've checked everything bigger. These are all possible pairs. So if I look, I've got 1, 2, 3, 4, 5, 6, 7, 8. I have 8 factors. That's an even number. Therefore, it's not a perfect square. No, 136 is not a perfect square. Plus, if we look, when we did our factors, there wasn't a number that multiplied by itself to get 136. Here are your practice questions. Again, same thing with extra challenge. Take a look at it at least. Whether or not you want to do it, that's up to you. After this, we are at quiz 1. So make sure you write quiz 1 before you go on to 1.3. Thanks very much.